everyone, this is NUNMAI AI, the SEBI Trust Chain, an AI-powered system for detecting and verifying financial impersonation attacks. Instead of just looking at one signal, our system combines four AI detection modules with an authentication layer to determine whether a financial communication is actually trustworthy. At the backend, everything goes through a common ingestion and orchestration API. We have four major detection modules: the phishing detection, synthetic voice detection, deepfake video detection, and AI-generated social media detection. And connecting all of them is our key component, NUNAI Verify, our SEBI trust chain. Let us now start with the phishing attack. Here I have a demo mail which is to impersonate the SEBI authorities, as you can see here. Here we upload an email claiming to be from SEBI. Our phishing module does not depend only on traditional signals. We combine URL and header analysis with transformer-based classifiers such as DistilBERT or Roberta to identify linguistic and AI generation pattern. We then perform entity verification. So when the sender claims to represent SEBI, we check whether the identity actually exists in our verified registry. So here you can see that this email shows a strong sign of being a phishing scam, and we can see why it is also flagged. So we can also see the phishing probability. Next, the attacker sends a video of the supposed executive. This is where our deepfake detection model comes into picture. We analyze both spatial and temporal information. A CNN-based component extracts visual features from individual frames while extracting LSTM analysis inconsistencies across the sequence. Architecture can use ResNetX for spatial features extraction and LSTM for temporal analysis, trained using datasets such as Face Forensics++ and DFDC. The output here is the deepfake probability along with the detection identity. So here you can see the entire log where every frame by frame is calculated, and a total of 57 frames are given, and each frame is flagged with different confidence rates, and an overall average is taken to determine whether the entire video is deepfake or not. Now let's assume the attacker follows up with a phone call. The voice has been cloned to sound like the same official. So our synthetic voice detection module extracts acoustic features including MFCC's spectral centroid and zero cross rate and passes them through our deep learning classifier.
The air and the earth are curiously mated and intermingled as if the one were the breath of the other.
The model is trained to distinguish genuine speech from synthetic or a voice cloned audio. And here the system flags and the recordings are synthetic speech. So it separates into two different segments and takes an overall average, which flags as phishing. So you can see a lower rate due to the inconsistency, but it also flags it accordingly. Module focuses on AI generated social media campaigns. Here we analyze two levels. At the content level, we detect AI generated text, images, and videos. At behavioral level, we look for coordinated activity, things like synchronized posting, abnormal volume spikes, account clustering, and coordinated amplification. So instead of asking whether one post is fake, we can identify whether multiple accounts are participating in the same suspicious campaign. So here I have a demo content. The number of followers is 12. And this is the content of the post. So here you can see that only the text analysis score is projected here, and behavioral risk score is not functional due to the restrictions of Instagram and Facebook APIs. So once this is enabled, we can get a overall matrix here. But detection alone isn't enough. The most important question is, who is actually authorized to communicate with the investor? This is where NUNAI Verify comes in. We maintain a verified registry where the SEBI acts as the root of trust, with authorized broker, exchanges, and representatives linked to it. For our MVP, we are using an SQLite backend registry and verification API. Official communications can also be associated with a cryptographic hash or QR code, allowing investors to independently verify whether the communication originated from an authorized entity. Now let's combine everything. The investor receives the mail. The follow-up call, synthetic voice is detected. The video, deepfake is detected. And the identity claim is checked against our trust chain. Even if the person exists in our authorized registry, the communication itself fails the verification checks. Instead of treating these four as independent alerts, our orchestration layer correlates them into a single threat, executive impersonation attack. Finally, NUNAI generates a consolidated threat report containing the detected results, confidence scores, identity, verification, supporting evidence, and tamper evident QR code and hash. The entire system is exposed through our React White frontend and connected through our backend orchestration layer. NUNMAI doesn't just ask, is it fake? It asks, who sent it? Can we verify them? Can we prove the communication is trustworthy? Thank you.